Your phone is not built to last, and deep down, you already know that. 2 years in, the battery dies faster. 3 years in, the software slows it down. 4 years in, the screen starts flickering, and suddenly your carrier is on the phone, very politely telling you it is time to upgrade. Time to sign another contract. Time to hand over another $80 a month. For someone in their 60s or 70s living on Social Security or a pension, that cycle is not inconvenient. It is a quiet drain that never stops. Now there are reports and patent filings suggesting Tesla may be engineering a foldable Pi phone, built to run 5, 7, maybe 10 years without forcing you back into that cycle. Not confirmed, not on sale, but the engineering ideas behind it are real. And today we are going to break down exactly what they mean for you. One important note before we start: Tesla has not officially announced any foldable Pi phone. Everything in this video comes from patent filings, engineering analysis, and industry reports. If anyone asks you to send money or give your Social Security number for a pre-order, that is a scam. Walk away. Why foldables usually fail? Most people think foldable phones are about having a bigger screen. But here is the real question nobody asks out loud. Would a foldable phone survive 5 years in the hands of someone who is not gentle with technology? Because that is the honest test, not the launch video, not the first 3 months. The real test is what happens after 1,000 days of putting it in your pocket, setting it on a hard surface, opening it one-handed while you're reaching for your coffee. Building a foldable prototype is not difficult. Dozens of companies have done it. Samsung, Motorola, Google, they all have foldables on the market right now. The problem is not making it fold one time. The problem is making it fold reliably for years. Here's what typically goes wrong. Foldable phones fail in predictable ways. The hinge loosens. Dust works its way into the folding cavity. The screen develops a deep crease you can feel under your thumb. And heat builds up in ways a flat phone never has to deal with. None of those problems show up in the first few months. They show up after thousands of open and close cycles. They show up around year 2 or 3, right when your warranty has expired and your carrier starts calling. For someone who plans to keep a device 5 to 7 years, that pattern is not acceptable. And that is exactly where the reported Tesla engineering philosophy becomes interesting. The hinge is the heart of any foldable. If it fails, nothing else matters. Most foldable displays bend sharply along one line, hammering the same spot thousands of times until a permanent crease forms. Patent filings suggest Tesla would use a water drop hinge design. The screen curves across a wider arc, spreading mechanical stress instead of concentrating it. Reported target: 600,000 folding cycles. At 100 opens per day, that is over 16 years. Then there is the problem nobody talks about. Dust is the silent killer. It works into the hinge cavity, grinds against the mechanism, and destroys it from the inside, slowly and invisibly. Tesla's filings describe a self-cleaning system, fiber sweepers, internal exit channels, near-zero gap closure when folded. Not to keep dust out entirely, that's impossible, just to give it somewhere to go before it becomes damage. And if the hinge is the heart, the next question is what skeleton is holding it in place? The center spine. Most people focus entirely on the hinge. Engineers focus on the frame surrounding it. Here is why. Your phone takes a beating every single day. You sit down with it in your pocket and the chair pushes up against it. You pick it up with one hand while the other half hangs in the air. You lean it against something at an angle. Each of those moments introduces small twisting forces that most phone frames were never designed to handle. For a flat phone, those forces are absorbed easily. For a foldable, they travel directly to the hinge axis.
If the frame around the hinge flexes even slightly, even by fractions of a millimeter, the hinge axis slowly drifts out of alignment. When that happens, creases deepen faster, the hinge begins to feel loose, and long-term reliability collapses in ways that are expensive and often impossible to repair. Some structural design discussions suggest Tesla's approach would use a single-piece center spine beam running the full length of the hinge axis, not multiple screws holding stacked subframes together, one continuous structural component. Fewer joints means fewer failure points. Higher rigidity means the hinge stays in alignment even after years of daily handling stress. Reported structural targets described in engineering analyses include body twist under 0.2 degrees during normal handling and hinge axis deviation under 0.05 millimeters across the full product lifecycle. Those numbers sound small because they are small. That is precisely the point. The difference between a foldable phone that still feels tight after 4 years and one that wobbles after 18 months comes down to tolerances measured in fractions of a millimeter. Tesla has been engineering to tolerances like that in their vehicles for years. The battery packs in a Model Y have structural specifications that would make most consumer electronics engineers uncomfortable. Applying that same manufacturing discipline to a phone hinge is not a stretch. It is a direct application of an existing capability. You would never think the part that breaks most expensive phones has nothing to do with the screen, but the next section explains exactly what does.
Heat. Foldable phones encourage heavier use. When a screen opens up to near tablet size, people naturally start doing more at once. Maps running in one half, a text conversation in the other, a video call with the grandkids, navigation audio in the background. That kind of multitasking pushes a processor harder and longer than any single-task smartphone use ever demands. In a normal flat phone, heat concentrates near the processor in one corner. The phone gets warm in that spot. The system either throttles performance, meaning it deliberately slows down to manage the heat, or it stays fast and becomes uncomfortable to hold. Neither option is good when you are in the middle of something important. In a foldable phone, the problem compounds. You are now holding a device roughly the size of a small notebook, generating heat in a space that was never designed to dissipate it evenly. Hot corners, uneven surface temperatures, performance that starts strong and degrades noticeably over a 20-minute video call. Some engineering discussions describe what they call a thermal manifold approach for the Pi phone concept. Instead of routing heat through a single pathway near the processor, heat gets distributed simultaneously across multiple routes, through both halves of the device, through the spine area near the hinge, away from any single point of contact where your hand rests. The goal is to prevent a permanent hot corner from developing during extended use. Reported thermal targets suggest grip area temperature staying under 42 degrees Celsius during heavy workloads and sustained performance maintained at roughly 80% of peak capacity, even under extended load. For context, 42 degrees Celsius is about 107 Fahrenheit. Warm, but not the kind of heat that makes you put the phone down, the kind of warmth you barely register versus the kind that forces you to set the device on a table and wait. For someone making a long video call with family or navigating an unfamiliar area at night, that thermal stability is not a luxury. It is the difference between a device that works when you need it and one that gives up exactly at the wrong moment. Balance and battery. Pick up any current foldable phone and notice something immediately. One side is heavier than the other. The processor, most of the battery, and the bulk of the electronics all sit on one half. When you unfold the device into tablet mode, that imbalance makes it feel awkward, like holding a book where all the weight is on one cover. Over time, that weight imbalance does more than feel uncomfortable. It puts uneven mechanical stress on the hinge. The heavier side pulls the pivot axis slightly off-center with every single movement. That accelerates hinge drift, the same structural problem we covered earlier, at a rate far faster than a balanced design would allow. Some design concepts suggest Tesla's approach would use two separate battery cells, one placed in each half of the device, rather than one large cell concentrated on one side. Reported total capacity of around 5,200 mAh, split roughly evenly between the two halves. The balance improvement that creates is something you would feel immediately in your hand. Reports suggest weight difference between halves could stay under 3 grams. 3 grams is the weight of a single penny. At that level, the human hand essentially cannot detect the imbalance. The phone feels like a unified object when open, not like two components fighting each other at the fold. The longer-term benefit runs deeper than feel. Two smaller cells charging simultaneously generate less localized heat than one large cell charging alone. Less heat during charging means less thermal stress on the battery chemistry over time. And that leads directly to the single most important specification for anyone making a careful purchase decision. What I'm about to tell you is the number that should make you angry at every carrier you have ever had.
Battery longevity. Here is a number worth sitting with. The average smartphone battery retains roughly 80% of its original capacity after about 500 charge cycles. If you charge your phone once per day, that is 500 days, less than a year and a half, before you notice your battery draining faster than it used to. By 2 years, most people are plugging in twice a day. By 3 years, the battery is a liability that affects every hour you use the device. The phone did not wear out, the battery did, and the manufacturer designed it that way, knowing the upgrade cycle would follow. Some engineering discussions around the Pi phone concept reference battery longevity targets borrowed directly from Tesla's electric vehicle battery technology. The specific target discussed, maintaining around 80% capacity after 1,200 charge cycles, rather than 500. At one charge per day, 1,200 cycles represents over 3 years before noticeable degradation begins, more than double what most current smartphones deliver. If Tesla's cell-level battery management systems from their EV platform translate to a phone format, actively managing thermal output during charging, balancing load between the two cells, preventing the overcharge conditions that accelerate cell degradation, that target becomes genuinely achievable rather than marketing language. For someone who wants to buy a phone once and simply use it without managing battery anxiety, without carrying a charging cable everywhere, without watching a perfectly functional device become unusable because its power source was designed to fail, that longevity specification rewrites the economics of the entire purchase. One phone, bought once, used for years. That is the math that matters on a fixed income.
Real-world durability. Here is something the foldable phone market has gotten consistently wrong. Most foldable phones are designed to impress in a showroom. Mirror-finish glass backs, polished bezels, colors with names like Phantom Black and Icy Blue that show fingerprints within 40 seconds of leaving the box. They look impressive on a display table, and they are not built for the real world. For someone who carries a phone in a work pocket, a fishing vest, a jacket alongside keys and loose change, a phone is a tool. It gets dropped, it gets scratched, it takes corner hits on countertops. A device engineered to impress buyers in a store was not engineered to survive the actual conditions of daily life. Some design discussions suggest Tesla's approach would prioritize what engineers call industrial durability over cosmetic aesthetics.
micro-textured metal surfaces that hide minor scratches by blending them into the existing texture rather than displaying them as bright lines. Frame geometry designed to absorb impact energy at the edges, the most common point of contact in a drop, rather than transferring that energy inward toward the hinge and display. Surface finishes where minor damage disappears visually, rather than becoming a permanent record of every bump the device has taken. Even small frame deformation matters enormously in a foldable. A slight bend in the outer frame creates a new gap at the fold. That gap becomes an entry point for dust. That dust slowly damages the hinge mechanism from inside. A durable outer frame is not cosmetic protection. It is the primary defense for every mechanical component housed inside the device. For someone who has spent decades working with equipment that was expected to function in real conditions, not laboratory conditions, that design philosophy is not a selling point. It is a minimum standard.
Who should buy and who should wait? Let us be honest about this. A foldable phone is not the right device for everyone, and this channel is not in the business of pretending otherwise. If you primarily use your phone for calls, texts, and occasional email, a foldable format delivers almost no practical benefit over a standard smartphone. The larger screen, the additional mechanical complexity, the thicker profile when folded, none of those trade-offs justify the cost for basic communication needs. But if you struggle with small text, if you use maps and navigation and the screen consistently feels too small, if you video call family and want them to feel present rather than thumbnail-sized, if you are currently carrying both a phone and a tablet and paying to keep both running, then a large, stable, durable, foldable display changes what daily life with a device actually feels like. The scenario where it makes the most sense: someone currently maintaining both a phone and a reading tablet, 2 devices, 2 charging cables, 2 separate monthly considerations. A well-built foldable collapses that into one. The scenario where it does not make sense: someone whose phone sits on a table most of the day and gets used for 10 minutes at a time. The added size and mechanical complexity brings zero real benefit to that use pattern. One more thing before we close, and this one matters especially if you've been following Pi phone coverage for any length of time. The reality check. Right now, in early 2026, there is no confirmed Tesla foldable phone. What exists are patent filings describing mechanical hinge architectures, thermal management systems, and structural frame concepts consistent with the engineering direction we covered today. What exists are supply chain signals suggesting development activity beyond the concept stage. What exists is a company with documented, demonstrated capability in battery chemistry, precision manufacturing, and the kind of long-cycle life product engineering that consumer electronics manufacturers have never had to think about before. What does not exist is an announcement, a price, a ship date, a product page. Anyone offering a pre-order link for a Pi phone foldable is running a scam. Anyone claiming to have a wait list that secures early access is lying to you. The rule is simple, and it never changes. If Tesla confirms something real, it appears on Tesla's official website. Nothing before that is real. This channel will not tell you something is confirmed when it is not. What this channel will do is track every credible signal, patent disclosures, supplier reporting, official statements, and translate it into plain language the moment anything verifiable surfaces. No hype, no pre-order pressure, no urgency manufactured to make you act before you are ready. Just the facts that help you make a careful decision. Here is what I want you to take away from this video.
Whether the PiPhone Foldable ever reaches production or not, the engineering priorities described in these filings represent something genuinely different from what the phone industry has offered for 20 years. Not which device has the most impressive launch, not which phone photographs best on a store shelf, but which device was built from day one to still be working reliably 4 years later without forcing you into another upgrade, another contract, another bill you did not choose. At 65, 70, or 75, the question is never which phone is newest. The question is which phone you can trust. Which device does not treat your fixed income as a recurring revenue source. Which phone was designed for someone who made a careful decision and deserves a device that honors it for years. That is the standard this channel holds every product to. If this video gave you a clearer picture, hit like right now. 1 second. It helps this reach people who need honest analysis instead of hype. Now drop a comment and tell me this. What is the one thing about your current phone that frustrates you the most? The bill, the battery, the size, or something else entirely? I read every single one, and your answers shape exactly what this series covers next. Not subscribed yet? Hit that button and turn on the bell, because the next video in this series covers something that affects every senior on a fixed income with a smartphone right now. The true 10-year cost of staying with your current carrier versus switching to a Starlink-based alternative. The numbers are going to change how you look at your phone bill permanently. You do not want to miss it. Stay sharp, stay skeptical. See you in the next one.